All right, let's take a look at question number 2. So for problem 2, we're going to find y prime, where y is equal to 1 divided by the inverse cosine of 3x. Okay, so if you take a look at this function, we're going to be making use of the chain rule twice. This is the composition of a rational function, um, an inverse trig function, and a linear function. Okay, so we're going to be using the chain rule here. So let's take a look at the order of differentiation. If I can rewrite this, in order to avoid using the quotient rule, I can rewrite this function as y equals the arc cosine or inverse cosine of 3x raised to the negative 1 power. Okay, so no, this negative 1 right here is the inverse of cosine. It's not reciprocation. So if you write this as cosine 3x by reciprocating this function, that will be inaccurate. Okay, so this is the correct way of writing it. All right, so let's go over the formulas we're going to be using for this problem, formulas. The outermost function, the reciprocal function, is a composite function, so we're going to be using d dx of u to the negative 1, okay? So that's going to be negative 1 u to the negative 2 du dx. Or it could be written as negative 1 over u squared du dx. So this du dx component just indicates that you're going to be doing the chain rule. All right, when we're done with the negative, with the reciprocal function or rational function, we're going to shift our attention to the inverse cosine function. So if we find the derivative, d dx of arc cosine of u, I'm using u here because we're going to be using the chain rule, that is going to be negative 1 over the square root of 1 minus u squared du dx. All right, because this is a composite function too. And then lastly, we're going to be left with the linear function on the inside. That one we're just going to go d dx of 3x, which is just simply 3. Okay, so if we combine all these functions together and plug in the respective values of u, then we should get the derivative. All right, so let's go ahead and do it. So starting with this right here, y prime is going to be, let's see, negative 1. Let's shift this to the left a little bit. Negative 1, applying the power rule to the outer function, negative 1 times the arc cosine of 3x raised to the negative 2 power. Okay, so that's the first rule here, negative 1 u to negative 2, or I could have written it as negative 1 over arc cosine of 3x squared. Now we're going to shift our attention to the next composite function, arc cosine of 3x. So that derivative, we're going to use this formula right here to do it. All right, so that one is going to be 1 times negative 1 over the square root of u squared, right? So square root of 1 minus u squared. U is 3x in this case, so it's going to be minus 3x squared. All right, so that's the second differentiation. And then lastly, the innermost function 3x, if you differentiate 3x, you're going to have 3. All right, so let's rewrite this in a nicer way, simplified form. So we're going to have y prime equals, in the numerator is going to be negative 1 times negative 1 times 3, which is positive 3. Positive 3 divided by, in the denominator I'm going to have the arc cosine of 3x raised to the second power times the square root of 1, and then when you square 3x squared, 1 minus 9x squared. All right, so there goes the derivative of the arc, 1 over the arc cosine of 3x. All right, let's take a look at question number 3. So for question 3, we're going to find the velocity function. Find the velocity function for the position function x of t equals the arc secant of 4t to the fourth power. Okay? So remember, if you want to find the velocity given the position, you're going to just differentiate the position function once. All right? So v of t is basically x prime of t. So what this problem is doing is asking us to differentiate this function once. Okay, so v of t is going to be x prime of t, which is uh, arc secant of 4t to the fourth prime. All right, the derivative of that. All right, so let's look at the formulas we're going to use to find the derivative of this composite function. The outermost function is the arcsecant function. So um, it's arcsecant and is also a composite function, so we have to use a chain rule for that. So d, we're going to use the formula d dx of arcsecant can also be written as secant to the negative 1 of u. U because the argument or the input of the arcsecant function is a function. So we have a composite situation here. So we're going to use arcsecant of u. So the derivative of this is 1 over the absolute value of u times the square root of u squared minus 1. And since we're using the chain rule, times du dx, basically the derivative of the inner function. Okay, and then when we're differentiating the inner function, we're basically going to be using the power rule here. Let me just make sure yeah, so that's how it's going to be. In this case, we're differentiating with respect to t, so let's be consistent with that. So d dt, since that's what we're looking for with respect to time, d dt du dt. All right, and then when we're doing the innermost function, we're going to be differentiating d dt of 4t to the fourth. And that one, for this one, we just use the power rule, and it's going to be 16 t to the third power. All right, you don't need the chain rule for the innermost one. So that's basically what we're going to have. If I multiply this by that and substitute the value of u into that, that will be what the derivative will be. Okay. All right, let's go ahead and apply to this function. So v of t, the velocity function, which is going to be the derivative of arcsecant. So the derivative of arcsecant using this formula is going to be 1 over the absolute value of 4t to the fourth, okay, times the square root of u squared minus 1, where u is 4t to the fourth. So it's going to be 4t to the fourth square minus 1. All right, so that's how it's going to be. All right. All right, and then we're going to differentiate the inner function, okay? Now we're going to differentiate the inner function. When we differentiate the inner function is 4t to the fourth. So basically we're going to apply the power rule here as we did over here. And then it's going to be times 16t to the third. All right, that's du dt. Okay, let's go ahead and simplify this a little bit more. Now let's examine this denominator right here. If you notice, we're taking the absolute value of an even power. Okay, if you're taking the absolute value of an even power, the absolute value sign is pointless, or it has no value, because the fourth power is going to ensure that this t is always going to be positive. So since that doesn't play any role, we can completely drop the absolute value bars. So let's put the numerator first, 16t to the third over. Now in the denominator, absolute value 4 is 4, and then t to the fourth because of the even power, all right? And then that times the square root of 4t to the fourth square is going to give us 16. If you use the product of a power property of exponents, you square the 4, which is 16, and when you square t to the 4, you have t to the 8. minus 1. All right? If you notice, we can simplify the numerator. If we divide top and bottom by the GCF, which is 4t to the third power. So we can divide the top and bottom by 4t to the third. Okay? If I do that, my final answer, on the top I'll be left with 4. And then in the bottom I'll be left with t. It's t by itself. T times the square root of 16t to the 8th minus 1. So this is basically your velocity function given this position function x of t equals the arcsecant of 4t to the 4th power. So there you have it.